All right, so today we're going to fill out a chart that's going to help us figure out when we factor certain things. So these are going to start getting mixed up, and you're going to have to figure out whether you need to factor out a GCF, whether you're going to factor by grouping, or whether you're going to do the T-chart and factor a normal quadratic, okay? So let's look at when we are going to factor out a GCF. So you can factor out a GCF when they have a number in common. So when there is a number or a variable in common. Okay, so this should kind of be the first thing that you think about when you see a problem. You should ask yourself, can I factor something out? Is there something that they have in common? Is there a number they all have in common? Or is there a variable that they have in common? So remember, when you're factoring out a GCF, you want your answer to look like you're taking out something like a GCF, and then you've got something in the middle. You could have 2 terms, you could have 3 terms, you could have 5 terms, does not matter, okay? So some examples of what that looked like. You can obviously have multiple letters like 8y x squared plus 2y x z, okay? Because the only thing that we can factor out of this would be a 2. Or you could have an example like 16x squared plus 8x, okay? So they've got something in common, and that's all you can do, okay? Now, there's also going to be when you can factor by grouping. And remember, when we factor by grouping, that's when you have 4 terms. Okay, so if you see 4 terms, maybe see if you can factor by grouping, but you have to make sure they have nothing in common. So there's no GCF. Okay, because if there was a GCF, then you could factor it out up here. So you can factor by grouping when there are 4 terms, but there's no GCF. So an example of that would be 2x cubed. So remember, they usually start out with the cubed, plus 4x squared plus 3x plus 6. So I've got 4 terms. Remember, they're going to typically start with the cubed. Okay. Now remember, your answers for factoring by grouping are you're going to have 2 parentheses. And if your problem starts off with the cubed, remember you could always take out like an x squared plus some number, and then you typically had an x plus some number over there, okay? So let's actually refresh your memory on how to do this problem. When you factor by grouping, you'll split it in 2, and you'll find the GCF, which would have been a 2x. You'll do your parentheses to divide and get x plus 2. Again, you rewrite that answer when you factor by grouping to find that outside GCF, and just divide those numbers. 6 divided by 2 is a 3. And then again, you write your answer 2x squared plus 3 in one parenthesis. So you could even say these are your GCFs, parenthesis, and this is the parenthesis that repeats. Okay. So again, that is when you can factor by grouping. Okay. And then lastly, the most recent thing we learned is how to factor a quadratic trinomial. So when you can factor a quadratic trinomial, it's going to be in the form ax squared plus bx plus c. Okay? So you can do that when there are 3 terms. Okay? And it starts with an x squared. Again, it could be a squared or b squared or whatever, but it's going to start with the squared, okay? So some examples of that, we've seen x squared plus 4x plus 3, okay? Remember, that's a shortcut example because my a is a 1. But when you factor a quadratic trinomial, that's when you multiply a times c and you do your T-chart, and you would get a 3. Your b term goes on the right side. You list the factors of a 3, so 3 times 1, that ends up getting you to a 4. And since this is a shortcut, my answer would be x plus 3, x plus 1, okay? So remember, your answer when you factor a quadratic is going to typically be 2 parentheses, They're both going to have an x, and they're both going to have a number. Okay, so plus, minus doesn't really matter. Okay, so they are going to be linear examples typically. Okay, so those are the three kinds of factorings that we've learned. And so now we're going to start jumbling them up, and you have to figure out whether you need to do the t-chart, or whether you need to factor something out, or whether you need to go ahead and factor by grouping. All right, but before we do that, I'm going to teach you two special cases on the back, and then I'm going to let you guys practice. So these are called special because something's a little different. So what do we notice about 2x squared plus 2x plus 16? Well, I notice that it's a quadratic trinomial. So typically, I would think to do the t-chart. But doing the t-chart is actually not the first step. So the first thing you have to ask yourself is there a GCF? Okay, so there is a GCF because a 2 can go into a 12 and a 2 can go into a 16. So the reason this case is special is because there is a GCF. So when there is a GCF, you have to factor it out first. So I'm going to factor out a 2 from this trinomial. So then I'm going to divide to see what's on the inside, and I would get x squared plus 6x plus 8. Okay? So then if you take a look and just look at this inside, then it's something like we've done in the past. It's actually a shortcut example of factoring a quadratic. So now I'm going to do the t-chart and multiply my a times a c. So 1 times 8 is 8, and my b term is a 6. So then I'm going to list out the factors of an 8. So 1 times 8 and 4 times 2. I know that 4 plus 2 will get me to a 6, so 4 and 2 are my answers. Now, since this was when a is a 1, I can go ahead and rewrite 4 and 2 inside the parentheses as x plus 4 and x plus 2. Now, the only thing you have to do is bring down that outside GCF. Okay? So now, you can totally have a number on the outside. So now you can have a number on the outside if you had to factor it out in the very beginning, okay? So not that tricky. You just have to ask yourself, is there a GCF before you just assume you're going to do the t-chart. So why don't you try this bottom one, see if you can factor out anything, and then solve that quadratic by factoring in the t-chart. Press pause. I noticed that a 3 could go into a 48 and a 180. So what I did was I factored out a 3. And so I divided to get this inside trinomial, and then I noticed my a was a 1, so I could do the t-chart. I noticed it was a shortcut way. So list all the multiples of 60, and you had to make them both negative, because to multiply to get a positive and add to get a negative, you've got to have both of your signs negative. So I saw negative 6 and negative 10 will get me to a negative 16. So again, since this was the shortcut, I can go ahead and put x minus 6 and x minus 10 in the parentheses. And just do not forget to drop down that outside GCF, okay? All right, so one more thing, another special case. So what is nice or not nice about this problem? Notice it's missing something. Something is missing. There's not 3 terms. So there's not 3 terms. To be more specific, there's something missing. The middle term is missing. So there's no middle term. So there's no x term. Okay? So when that happens and there is no x term, it's got a nice name. Whoops. It is called difference of squares. Okay. So now, obviously it's named difference of squares for a reason. So notice it's named difference because there is a subtraction sign. There will always be a subtraction sign for this to happen. It's called square not because of this squared up here. We need to look at 16, 25, 9, and 64. Now, hopefully you remember your perfect squares. Okay. Your perfect squares are 1 times 1 is a 1, so 1 is a perfect square. 2 times 2 is a 4, so 4 is a perfect square. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is a 100. Okay? So if you see any of these numbers, that means they are perfect squares. And that means you can do the difference of squares. So if there's a subtraction sign and then a missing middle term, and your two numbers are perfect squares, this is when this can happen. So what you do is you take the square root of each number. So you square root each number. So for example, I'm going to start off with 2 parentheses because that's what my answer usually looks like. The square root of a 16 is a 4. Okay, so I'm going to have 4 in each of my parentheses. Then I'm going to split up my x to get that x squared. And then 25, the square root of 25 is 5. So I'm going to have a 5 here and a 5 here. And then your signs are going to be 1 positive and 1 negative. Okay? The reason for that is because a positive times a negative is a negative. Okay? So you've got to get that negative up there for difference of squares. Okay? So again, if you're missing the middle term and these two numbers are perfect squares, square root them and then put them in a parenthesis, one with the plus, one with the minus. Okay? So why don't you try this one, and I'm going to give you a second one. Why don't you go ahead and try 81a squared minus 100. Okay? So you try those two problems and press pause and we'll go over it. All right, so for the first one, I got 3x plus 8 and a 3x minus 8. So again, 9 and 64 are perfect squares. So the square root of a 9 is a 3. The square root of 64 is an 8. So I put x's on both of them, and again, 1 plus and a 1 minus. Your order does not matter. Over here, square root of 81 is a 9, so I had 9a on both of them. And then 100 square root is 10 and 10, so again, 1 plus, 1 minus. Okay? So that is how you do difference of squares. Now, something to realize is if, for example, I had 16x squared plus 25. Can you do the difference of square on this problem? And the answer is no. Okay? You cannot factor this problem at all. So you would say cannot be factored. And the reason is because this is a plus sign. Okay? So for difference of squares to happen, you have to have a minus sign in between them. So if you see perfect squares with a plus in between them, you cannot factor those terms out. Unless they've got something in common, okay? But that would be it. So again, difference of squares, you got to have a minus sign and then two perfect squares on each side of each other, okay? So now you know all the kinds of problems in polynomials that can be factored. So you've just kind of worked through your process of how to factor it. So do you need to factor out a monomial? Do you need to factor by grouping? Do you need to do difference of squares? Do you need to do a t-chart? So you're going to have to ask yourself those questions when you're presented with a problem, okay? So you're more than welcome to practice now. You can finish all your IXLs, or we've got some paper practice in a scavenger hunt. So thank you for watching.